Have fun.
Hi everyone, I'm Kara Wells. I'm an animal scientist and founder of Emgenisys. We are going to make the world a little bit better, starting with objective embryo health diagnostics in cattle for use by veterinarians like Dr. Killingsworth.
Hello, my name is Russell Killingsworth. As a veterinarian specializing in cattle reproduction, I've spent my entire career working to get cows pregnant. Why is this important? Milk. Milk is New York's #1 agricultural commodity. In order for cows to produce milk, we must first get them pregnant and allow them to give birth. To meet the increasing demands for milk, we use the breeding processes of IVF and embryo transfer on superior females like Carla, who is from right here in New York. These cows are DNA tested, and only those with the genetics to improve animal health, efficiency, and sustainability will be selected as donors. Embryos are collected from the donors and transferred to surrogates or recipients to produce multiple offspring each year. There are over 2 million transfers in the U.S. each year. Despite the widespread use, embryo transfer, or ET, is a delicate balancing act. It can certainly produce many more high-value calves, but for each recipient that does not become pregnant, there is an additional $300 cost because of the time delay until she delivers her next calf and begins milking again. These cows that do not become pregnant are called open cows. Economically, it is important to get these cows bred as quickly as possible. By the time I reach the Hudson Farms on the day to transfer 50 embryos, Mr. Hudson has already invested considerable time, labor, feed, and money in the process. The Hudsons are excited about the prospects of next spring's calf crop when these embryos will be born. But realistically, we only expect 50% of the recipients to become pregnant. Despite the technicality and expertise in these procedures, these results are disappointing and expensive. Why? Because research has shown that 20% of the embryos that we are transferring today are non-viable and have no chance of establishing a pregnancy. The problem is that today, we don't know which 20% are no good. This results in almost $2 billion in cost to American cattle producers each year. To get these cows pregnant as quickly as possible, it is crucial that I select a healthy embryo to transfer. To do this today, I make a subjective evaluation of a static image under the microscope. Because this is a subjective evaluation, even experienced evaluators do not have objective data to distinguish the 20% of embryos which are no good. If we knew which embryos were no good, we would not transfer them, and Mr. Hudson would be more profitable.
Well, at Emgenisys, we have developed a software solution to identify these poor embryos for use in the lab or field. To use our system, the veterinarian simply records 30-second videos of embryos in culture, uploads the videos to our website, where we analyze them frame by frame, checking each embryo for signs of life. We then send a digital report to the veterinarian, and they can use this objective data to select only the healthiest embryos for transfer, improving pregnancy outcomes 20%. It is the veterinarian that is our direct customer and user of this technology. Improving pregnancy outcomes gives them a competitive edge and increases client satisfaction. More people will feel confident using embryo transfer and IVF as breeding techniques, therefore growing our industry. While the veterinarian is the direct customer, the dairy producer is the indirect customer. Had Dr. Killingsworth used our technology on Mr. Hudson's 50 embryos, we would have known that 10 were not viable. We would have thrown them out and stopped wasting any more time and effort on them, saving Mr. Hudson recipient animals and over $5,000. For a large farm in New York transferring 8,000 embryos each year, these savings would be over $750,000 annually. We not only save the producer's bottom line at time of transfer, but we enable them to reduce the size of the recipient herd. Also, they will have a higher proportion proportion of cows making the money because they will be producing milk faster and give birth to valuable offspring, therefore improving their top line. We own the intellectual property for the use of this technology in all mammalian species, but we are aggressively targeting the United States cattle industry. With the need to test 5 million embryos each year, we have a $75 million market opportunity, and it's growing as there is a 17% increase in embryos transferred year over year. Successful launch for the use of this technology in cattle will help us scale into the $15 billion annual mammalian market, which includes the use of this technology for clinical human IVF. We will sell our technology with a usage-based SaaS revenue model in which we charge a fee for embryo tested. This is the best way to offer this technology to our customers with low upfront costs while providing Emgenisys with recurring revenue. Our pricing model allows a veterinarian to upsell this technology as a service add-on for their clients. We've talked to several veterinarians doing over 250 embryo transfers a week. These customers are repeat users and will have high lifetime value. Since last year, we've tested our technology on over 2,000 cattle embryos and used the pregnancy data to train our machine learning algorithms. We're growing our customer base with 15 veterinary groups in North America, a figure which we have doubled since being accepted into Grow New York. We've self-funded this venture and have not accepted any dilutive capital. Now, it's time to disrupt an industry. History was changed by ag innovation, and we will do it again. And we'll do it here in New York, where dairy is forward-thinking and revenue-generating. Our beachhead market is the veterinarians serving the progressive dairies. These customers are already comfortable using digital technology. We're already working with several of these groups for research, and others are eager to adopt our technology upon launch. Next, we can scale into larger customer segments, which include large IVF enterprises and embryo marketing groups. These customers perform hundreds of thousands of embryo transfers each year, and many have locations internationally. When talking to executives of these companies, some say that they're willing to adopt new technologies if it allows just a 1% improvement in pregnancy outcomes. To access these customers, we will leverage existing contacts, participate in industry conventions, and make key hires for product demonstration. With this plan, we can generate over $3 million next year. While ambitious, it's feasible due to the relationships that we have built and demand to improve profit margins of animal production. I want you to notice that securement of key customers or a software partnership can help us exceed our goals and scale faster. We have received overwhelming support from New York. We now have the contacts and research commitment to do collaborative research with Cornell University, as well as local veterinarians and dairies. We've also met with several engineering groups in the area with the skill sets to improve product performance, app development, medical imaging capabilities, and possibly integrate our software into software platforms already in use by the dairy industry. The timing is right for us. We have first mover advantage in an eager, readily available market. Funds and prize money can drastically shape our future. We will use the funds for key hires to support product development, engineering, dairy outreach, and sales. The first thing we will do is set up a mobile lab to test our product, communicate with dairies, and train veterinarians to use our technology. With $250,000, we can create 5 jobs. With $1 million, we can create 14 jobs within 6 months of fund disbursement. This creates 360 degrees of impact for the region. The people we hire will lead innovation, creating more demand for engineering and research. Launching our technology for use in dairy helps improve the profit margins of the people who already live and work here, keeping wealth in the region. Also, we'll help provide positive global impact by helping make more protein from fewer animals, thus providing increased global food security and reducing the carbon footprint of animal production. Our team has over 50 years of embryo expertise. We built our software through engineering collaboration with students. Some of our founders are also owners of Ithaca Milk and also provide patent protection and business development expertise. With these new and existing ties to New York, we're well positioned to thrive. So join us, New York. We're breeding something epic. And please laugh at my cow.
Great job.
Thank you.
All right, well done. So we have just over 9.5 minutes for questions. Let's lead off with you, Mary.
Yeah, thanks. That was super. That's exactly I love these pitches that are like, okay, here's the problem and we have a solution for it. So, and it seemed elegant that way. So 2 questions actually. One, can you tell me more about your IP position? You said you owned it for all species. You were focusing here, but kind of what is that IP position? And then just to give you one to think about is what could go wrong?
Absolutely. So we have a patent pending with the PCT filed, and this protects the non-invasive evaluation of embryos through video data. What could go wrong? Great question, and that's why we've made sure that our technology is non-invasive. We don't want to manipulate the embryos in any way, touch them, so using just digital video recordings and analyzing the videos, we know that we're not posing any risk to the embryos. Now, we don't say transfer or throw out. We give a confidence interval, and it is the veterinarian with the subject matter expertise that can ultimately make the decision of whether to transfer or discard that embryo. Thank you.
Annie, over to you.
Great. I love the cow. It's awesome. Good graphic capability. I'm going to ask a very lay question, so bear with me. Data imagery is not new and not proprietary, so what makes your ability to analyze that unique and protective? And then the second question is, there's a lot happening in IVF, especially around, making sure that exactly the problem you're solving is being captured and cared for. So how do you compete in that landscape? I'd love to hear a little bit more about that.
Sure. So the first question, the video data. So we've used a series of filters to make morphokinetic activity, which you cannot typically see with the human eye under a microscope, humanly perceptible. So we are analyzing these amplified versions of the videos, and that's part of what makes us unique and able to perform these analyses. A little bit about my background is before starting this company, I actually did human embryology clinically, so I've seen the same problems that we described in cattle exist in clinical IVF too. To my knowledge, we still grade embryos with the subjective analysis by the embryologist, but there is competition in this space. One uses time-lapse imaging, which requires that you monitor the embryos for 5 days. Our analyses can be done in 30 seconds. The second is artificial intelligence for use on a single static one-frame image. So even though we're just doing a 30-second observatory period, we're collecting more data than you can gather in a single static image and try to use those tiny changes over time to make our predictions.
Thank you. That's very helpful.
Thank you.
John Caltabiano.
Thank you, Karen Russell, for making a very complex challenge understandable to us non-scientists. Love that you want to target New York, but being from another place, Texas and other places like that, why not California? Why not Texas? Why not some of those places to get launched?
Great question. So honestly, you guys have been very, very nice to us and very accommodating. I don't think the other places have done that. But the dairies up here are as progressive as anything I've seen in the rest of the country. There's a big presence with a lot of the large customers in New York, and You guys just seem willing to adopt the technology, and there's this also little thing called the Cornell School of Veterinary Medicine, which, you know, is also great research partners to have that can really just amp up our research tenfold.
Great. John Eng.
Also, I second that you could make something so complex understandable to me. Actually, you did answer my original question about your response time, that you can, a veterinary could upload data and get a response in 30 seconds. But thinking back a little bit, you said you've only had about 2,000 embryos analyzed. That doesn't seem like a very large pool to really base reliability on.
I agree with you. We kind of rely on our engineering partners to kind of coach us through what sample sizes that we need. But we have 2,000 embryos, 30 seconds, 15 frames per second. So we're actually filtering a lot of images through these machine learning models. And the prediction accuracy is performing really well. Russell has recorded every embryo that he transfers in his practice since April of 2020, and these 15 research partners, prospective customers that I mentioned, they're all sending us their data and pregnancy outcomes, so we kind of have a current influx of data that we are generating to keep building those models to improve our prediction accuracy.
And so I have a follow-up, and that was a great lead into my follow-up, because I'm sitting there thinking the data keeps coming in, and really this model is probably never static, right? So what's the thought process from here? Does it, I mean, you got this model, you've been using it, does it morph into something else eventually, or what happens?
It continues to self-improve. The more data you get, the better results we get back from it.
Great.
We really want to incentivize our first customers and all of our customers to self-report their pregnancy data so we can use that as positive or negative feedback for the models.
Can you tell me about the economics for the I know it's something that the veterinarians will use, but what does that cost to the farmer and the breeding program? Does that go up? What is the return? How do you quantify that?
One more. Okay, this is an example that we used here. Without Emgenisys, the vet charges $50 to transfer an embryo. So he makes $500 that day. The total dairy cost, when you figure in your days open cost on the recipients that are not pregnant, it cost him $2,000. If we charge $15 for the test, the veterinarian upsells that to $30 to the producer. The vet is now, even though he's transferring fewer embryos, his net is an increase. And even though the dairy is having to pay for the test because we've got fewer open recips, he has lowered cost in the equation.
Great. So John, do you have additional question? John C? Nope.
No, actually, I think you answered, because I was trying to figure out the revenue model, who shares in it, and you've answered. You're really saying both the vet and the, yeah.
Well, right.
But I'd like you to go, that's really helpful. I was really curious about that other. This is interesting. Can you explain to me the movement here and
Okay, from the upper left on superovulation, typical embryo transfer, or the upper right, IVF procedures, either way we get a collection of embryos that Emgenisys will evaluate. The farmer has prepared the recipients, they've been on feed, they've been getting shots to get their estrus period synchronized. Then we transfer those embryos, and the veterinarian charges approximately $50 per transfer, and then typically we will wait 30 days to do ultrasound to diagnose pregnancy. For those cows that are pregnant, they go right on. They're ready to deliver a calf, get back in the milk line. The problem is that after 30 days, 50% of those cows are still open. And so that's adding to the days open in the dairy, which is a big indicator in profits in your dairy is days open.
Great.
Thank you.